Alternate form that does not express in the F1, but reappears in 1/4 of the F2. But reappears in 1/4 of the F2 is referred to as
recessive.
recessive. Okay, is that clear? The allele governing such a form, is called as recessive allele. The allele governing a trait that is expressed in the F1 heterozygote itself is called as the dominant allele. Clear? Did you get it now?
Yes, sir.
Okay. However, we'll see how the meaning of when we deal with separate experimental material. The definition of dominance could change. How does it change? Now, for example, I'm sure you must have seen cattle with black and white patches, right?
Yes.
Of that expression, that is codominance. Okay. Now, the another kind of dominance, for example, you make a cross between pure breeding red flower plants when crossed to a pure breeding white flower plants, and if the F1 produces pink flower plants, then what do you call this kind of dominance?
Incomplete dominance.
Incomplete dominance or partial dominance. What is the reason for this?
Sir, the dominant allele does not able to express itself complete. Sorry, recessive one. It interferes actually, sir.
Interference action. Okay, we'll see how we can clearly understand this particular process. Okay. Now we talked about codominance as in case of coat color in cattle. Here, coat color in cattle is a case of codominance. We discussed flower color in some plant. Okay, let us say garden peas only. Okay, so when we make a cross between pure breeding red and pure breeding white, the resulting F1, if it is pink, then we say it is incomplete dominance or partial dominance. There's also something called as over dominance. Over dominance. What is this over dominance now? Now you make a cross between a white and a yellow, you get red, let us say. Did you get it? Did you get it?
No, sir, not getting, sir.
Let us say you make a cross between A and B. A is, let us say, white. I'll give a separate example, don't worry. B is yellow. You make a cross. You get F1. The F1, let us say, is red. The F1 is red. That means the intensity of the color is low in both of them, but very high here. It is over-expressing. Is that clear? I'll give a very classical example here, don't worry. Now, to explain, this is called as over dominance. Okay. Better explain this, I will consider here when it comes to over dominance, a dominant and recessive allele. Did you get it? Did you get it? With dominant allele, what? A form or an allele that's in the F1. The form or allele that doesn't express in the F1 but reappears in F2 is called as recessive, isn't it? But you cannot give the same kind of explanation for an example where there is partial dominance or codominance or overdominance. And let us see how we can explain that. Now, there are different ways of symbolizing genes. There are different ways of symbolizing genes or alleles. Either to what we were doing, we used to use an case and Uppercase andreno. What is the meaning of uppercase?
Dominant.
Dominant alla. Capital. Lowercase letter andre small letters. Did you get it?
Yes, sir.
To symbolize a gene, now if there are only two alternate forms of a gene, then you can use an uppercase letter to designate a dominant allele and a lowercase alphabet for a recessive form. So,
Yes, sir.
yeah. Now, further. Now, in genetics, we generally give more prominence or relevance to the mutant form. You get it? The wild allele or the dominant allele is not given that importance. The mutant allele is given more importance. For example, plant height. We know when we make a cross between tall and dwarf, when we produce the F1, tall is the F1, then in the F2 we have 3 tall and 1 dwarf. What is more predominant there? That is why it is called as dominant. Out of every 4 individuals, there are 3 individuals that are tall. That is dominant. The literal meaning of dominance is more prevalent. Is that clear?
Yes, sir.
Dominance simply implies that they exist by default. Okay? The less frequent ones are the mutant ones. The less frequent ones are, why less frequent? It is 1/4 only. Did you get it?
Yes, sir.
3/4 of them, that is 0.75 or 75% of the population is tall, only 25% of the population is dwarf. Clear? Now, we give more importance to the form that is least frequent, and that is called the mutant form. Is that clear? Now, please remember, without the mutant form, we cannot decipher the inheritance of any character. That is the reason why we give more importance to the recessive form. Is that clear? We have to invariably have a recessive form. Without the recessive form, we cannot understand the genetics of any character. Okay? Now, if there are only 2 forms, fine. You have A for dominant allele and small a for recessive. What do you call? Can all genes be called as capital A, small a? Can all the genes be called as capital A and small a? Then how do we use alphabets? Let us say now, for example, stem length or plant height in garden peas. What is important here? There are 2 forms. One is tall, the other is dwarf. Which is the mutant form? Which is the mutant form?
Dwarf, sir.
Dwarf. So we take the first letter of dwarf. We take the first letter of dwarf. To designate a gene, okay, we use the first letter of the mutant form. So to write tall, it'll sound very strange to you now. To designate tall, we use this. To designate dwarf, we use this. Is it clear? Is it clear?
Yes,
Now, all these years, what you have taught, capital D should be tall. No, you can still continue to use it. But when you're trying to designate or assign a gene symbol, You give more prominence or importance to recessive form. How do you give that? You take the first letter of the recessive trait, use that as a gene symbol. Well, it's good if you have only two kinds, but if you have more than two, then how do you do it? Then came the answer. Don't do it like this. Instead, you call it as D1, D2, D3. Or provide the scripts, D1. This is a subscript. This is a superscript. Is it clear? Existence of more than two alternate forms of a gene. Existence of more than two alternate forms of a gene, you call that as, you designate them as, designate the alleles as with superscripts or subscripts. Now imagine that we have a character controlled by a locus A with two alternate forms A1 and A2. Consider a character that is controlled by a gene A, and this gene has two alleles, A1 and A2. The reason why we say A1 and A2, we don't know which of these are dominant or recessive. Is that clear? Is that clear? Now, what is the homozygote here? Can you give the genotype of the homozygote? ಎಲ್ಲ ಮಲಗಿದ್ದೀರಾ? ಎದ್ದಿದ್ದೀರಾ?
ಎದ್ದಿದ್ದೀವಿ ಸರ್.
ಎದ್ದಿದ್ದೀರಾ? ಹೋಮೋzygote ಯಾವುದು? A1 is one homozygote. A2 is another homozygote. See, instead of capital A, small a, I have simply called them as A1 and A2. Is that clear? Is it clear?
Yes, sir.
Yes, sir.
Now, these two are contrasting. Let us suppose that I am now dealing with the trait that is measurable. I am now dealing with a character that is measurable. For example, I have a plant. Now, Mendel said one plant is tall, the other plant is dwarf. Okay. Now, let us assume the same character plant height, which is measurable using a scale. I measure this plant and say A1 produces a mean plant height. When I say mean plant height, I put a bar here. A mean plant height of 50 centimeters. Clear? Then I have another contrasting plant A2, which has, let us say, a mean plant height of 80 centimeters. Now I made a cross between these two. I get an F1. What is the genotype of the F1? What is the genotype of the F1?
A1, A2.
A1, A2. Now, I don't get one plant. I get a number of plants, right? Please remember, when I say 50 bar, this is the mean plant height of, say, 100 individuals of A1. This is mean plant height of 100 individuals of A2. Did you get it? Now, I made a cross between A1 and A2. I produced an F1. The F1 genotype is A1, A2 because this produces a gamete A1. Parent 1 produces a gamete A1. Parent 2 produces a gamete A2. A1 and A2 will fuse to give you the heterozygote A1 and A2. Is that clear? Now, imagine that it is not just one plant. I've told you earlier also, there could be a number of F1 plants. You take the average height of all the F1 plants. What is the expectation? Well, the average plant height of a number of F1, A1, A2 heterozygous individuals be equal to 50? Or will it be equal to 80? Or will it be equal to something other than 50 and 80?
So something other than 50 and 80.
Something other than 50 and 80. Oh, good, very good. Now, suppose that. Let us suppose that. This is a scale on which I am measuring the plant height. This is a scale with which I am measuring plant height. Okay. I have A1, A1 here. I have A1, A2, A2 here. I made a cross. Now we have the F1. Now this is, let us say, here we have some height. Okay, this is 50 centimeters. This is 55, 60, 65, 70, 75. Let us say something like this. Clear? Is it clear? This is a scale. Okay, you have 85, 90, 95. Similarly, you have 45, 40, and so on. Is it clear? It's a hypothetical scale. Now, let us suppose that I have two parental lines. One produces 50 grams of rice, the other plant produces 80 grams of rice. I made a cross between these individuals because I want to improve grain yield. I produce an F1. Now, the F1 plant will produce some yield. I take the average of it. The average could be 40, it will be 45, 50, 55. That means to say that the mean phenotypic expression of the F1, A1, A2 can fall anywhere on the scale. Is it clear? Is it clear?
Yes, sir.
Now, if the mean plant height of the F1, A1, A2 is equal to 50 centimeters, then what do you say?
A1 are the dominant. A1 is the dominant.
A1 is completely dominant to A2. A1 is completely dominant to A2. Did you get it?
Yes, sir.
You made a cross between A1, A1 and A2, A2. You have produced an F1. You have a number of plants. You have taken the mean of the F1 heterozygous A1, A2 plants and the mean of the F1 heterozygote A1, A2 plants happens to be 50. If it happens to be 50, then you say A1 is completely dominant to A2. Is that clear? If the F1 heterozygote A1, A2 had a mean phenotypic expression equal to 80 centimeters, then you would say A2 is completely dominant to A over A1. Is it clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, all this is understood. You have chosen two parental lines. One of the parental line A1 has mean plant height of 50 centimeters. Another parental line P2, A2 has a mean plant height of 80 centimeters. You made a cross, you have the F1. Now, the mean plant height of the F1 heterozygote can assume any value on the scale. We are now assuming if the F1 heterozygote assumes a plant height of 50 centimeters, then we say A1 is completely dominant over A2. If it assumes a plant height of A2, equal to A2, then we say A2 is completely dominant over A1. Do you agree? Do you agree? Now let us suppose that. The main phenotypic expression of the F1 heterozygote A1, A2 is equal to the average of the mean phenotypic expression of the two extreme parents. What are the two extreme parents? A1 is one parent, A2 is another parent. A1 is 50 centimeters, A2 is 80 centimeters, 50 plus 80 is 130 centimeters, divided by 2 is the average, 65. If the mean phenotypic expression of the F1 heterozygote A1, A2 is equal to 65 centimeters, then we say, what do we say here? Please see this, A1, A2. No, we say there is no dominance. Yeah, I think Banu has asked a question. Sir, can a mean height be less than 50 centimeters or greater than 80 centimeters? Yes, it is possible. Let us see. But first understand this. If the mean phenotypic expression or the mean plant height of the F1 heterozygote A1, A2 derived from a cross between two extreme parents A1 and A2, whose average plant heights are 50 centimeters and 80 centimeters. If the mean plant height of the heterozygote is 65 centimeters, then we say there is no dominance. How do you give an explanation to this? You say A1 and A1 put together produce 50 centimeters. Now, what is the effect of A1 alone? Now, two alleles put together is giving you 50 centimeters.
25, sir.
Yeah, this is 25 and this is 25. Clear? Now what about this one? This is 40 plus 40. Do you get it? Now what about this one? This is 25. This is 40. How much is it? 25 plus 40 is?
65.
65. Why do you call it as low dominance? We'll see later. We will see a bit later. So this is called as low dominance, or also it's called as codominance. That means to say that in the F1 heterozygote, neither A1 dominates A2 nor A2 dominates A1. Both of them have their independent effects. What is that independent effect? A1 produces a height of 25 centimeters, A2 produces a height of 40 centimeters. So both of them put together is 65 centimeters. That is the genetic explanation that we give when we'll have to say there's absolutely no dominance. So that means to say that the effect of the allele A2, though it is 40 centimeters, it is not suppressing the effect of the allele A1 that is producing 25 centimeters. Similarly, the allele A1, which is producing 25 centimeters independently, does not suppress the effect of the effect produced by allele A2. So therefore, both of them are independent. They will now add up and then give up 60 centimeters. Did you get it?
Yes, sir.
This is no dominance or codominance. Why codominance? A1 is expressing 25 units. A2 is expressing 40 units. Both of them put together is 65 units. I'm sure it's clear. This is a case of no dominance. Okay. Why no dominance? I'll come back later. So we have seen complete dominance in these two cases. This is no dominance. Complete dominance and no dominance. Now let us suppose that there's a possibility that when you make a cross between A1 and A2, you derive an F1 A1 A2. The A1 A2 F1 can have a plant height somewhere. Yeah. Is that possible? Between 50 to 65. Let us say something like 58. Now what do you say? If the mean plant height of the F1 heterozygote A1 A2, the mean plant height of the F1 heterozygote A1 A2 is equal to 58 centimeters, then we say A1 is partially dominant over A2. Is that clear? If it's something like 75, or 76, then we say A2 is partially dominant over A1. If the mean plant height of the F1 heterozygote A1 A2 is 90 centimeters, then we say A2 is over dominant to A1. If it is 40 centimeters, then we say A1 is over dominant to A2. This is cases of over dominance. Banu, it cannot be called as pseudo dominance. Pseudo dominance is something different, which I've studied in cytogenetics. The term pseudo dominance does appear in one of the kinds of structural aberrations, that is deletions. So, expression of a recessive allele in an individual that is hemizygous. Is that clear? I do not know if you are able to recall what was dealt the previous semester. Whenever there is a deletion in only one of the homologs, okay, something like this. I think this must have been dealt. And you have A, B, C, D. You don't have F, G, F, G. Then you have H, I, J. Then what happened? This is the E, F, G. We have studied this as deficiency loop or deficiency buckling, right? And if these alleles were to be recessive, if something dominant has been lost and if only recessive alleles are here, and if those recessive alleles come into expression, then we say it is pseudodominance. Recessive alleles come into expression only when there are two copies, whereas dominant allele can express itself only when a single copy of it is present. I think I'm sure you know this. A dominant allele can express itself even if it is present in only one copy, whereas the recessive allele will express only when there are two copies. Right? Here, in a deletion heterozygote, for some regions of the chromosome you have hemizygous condition, and if within this hemizygous condition you have recessive alleles, and if these recessive alleles come into expression even though they are present in only one copy, then that is called as pseudodominance. Arthaita? Who asked this question? Banu. Right. Okay. Did you understand? This is no to determine the kind of dominance that is involved in the expression of a character. We'll have to need to pick two individuals that are contrasting for a character that is measurable. Please underline this word measurable. Arthaita?
Sir, repeat the statement, sir.
Repeat the statement. Okay. To understand the kind of dominance that is involved in the expression of a character, you need to choose a pair of parental lines that contrasts or that differ for a character that is measurable. Artha aita?
Yes, sir.
Okay. Then what do? You choose two parents, then make a cross between them. Produce the F1. And see where exactly the phenotype of the F1 will fit into. Depending upon the position of the phenotypic value of the F1 on the scale that was used to measure the trait, you will be able to determine the kind of dominance that is involved in the expression of the trait. Any doubts in this? Any doubt? Yes or no?
So,
Yeah.
so to determine which type of inheritance is going on, whether it
No,
is
not. I didn't tell which type of inheritance. I told you which kind of dominance.
yes, sir,
No.
which kind of dominance?
Yeah. So there are
Like-
different kinds of dominance. Dominance, complete dominance, partial dominance. Okay.
Yes.
No dominance or co-dominance, over-dominance.
Yes, sir.
Yeah, tell me.
So then to determine which kind of dominance is going to express and to determine which kind of dominance exactly it is, so it has to be taken in how much, in at least how much of the population, so more than 50% or on one or two, like.
No, see, please understand. For all genetic studies, you'll have to use two parental lines.
Yes, sir.
We'll have to ensure that the parental lines are pure breeding.
Yes, sir.
When they are pure breeding, if you take the values on 100 individuals, there must be almost close to each other, the values.
Yes, sir.
Clear?
Yes, sir.
You have another contrasting type. You take 100 individuals of that. They should also measure the same. That is
Yes.
the mean. That is what I've indicated, the mean. Yeah. Mean is 50, mean is 80. Clear?
Yes, sir.
Then you make a cross. So you've identified, you know that these two individuals are contrasting. They are easily distinguishable. Then you make a cross between them, produce the F1, then see where exactly the value, phenotypic value of the F1 falls on the scale that was used to measure this trait. If the F1 phenotypic value falls here, then it is A1 completely dominant over A2. If it falls here, then you say A2 is completely dominant over A2. If it is equal to the average of the two, then you say there is no dominance. If it falls here, you say A1 is completely over dominant to A2. If it falls here, then you say A2 is over dominant to A1. If it falls somewhere over here, then you say A1 is partially dominant over A2. If it falls here, you say A2 is partially dominant over A1. This is dominance. This is complete dominance. This is complete dominance. This is over dominance. This is over dominance. This is partial dominance. This is partial dominance. This is no dominance. Did you get it?
Yes,
Have you
sir.
now? Huh?
Yes, sir. Sir, in F1, if we get total 100 offsprings after crossing A1 and both the parents, sir, in those 100, sir, if nearly more than 50 of the plants are falling in one of the category, then we can assign that character as that of a particular.
No, you can. But here we are taking a character that is quantitatively inherited. So you'll have to take the average of all of them.
Okay, sir. Okay, sir.
Okay. Now, irrespective what height the individual assumes, the genotype of all the F1s is the same.
Yes, sir.
The genotype of the F1 is all the same because you made an individual cross between parents that are homozygous or pure breeding for this locus.
Yes, sir.
Did you get it? That is
Yes.
why I've been telling you the F1 individuals are genetically similar. Is that clear?
Okay, sir. Yes, sir.
Okay, now, can we now define dominance in one line? Immediately after that, I'll stop. Can we now define dominance Now, see here, this is complete dominance. This is also complete dominance. This is partial dominance. This is partial dominance. This is no dominance. This is over dominance. Then what is dominance? Please note down. Deviation in the, I'll explain later. Deviation in the mean phenotypic expression. Deviation in the mean phenotypic expression. In the bracket, you can write as plant height, let us say. Deviation in the mean phenotypic expression of the F1. From where? From the average of. From the average of. The mean phenotypic expressions of the homozygous contrasting parents involved in generating the F1. What is important? Don't worry about all that. Deviation in the mean phenotypic expression of the F1 from the average of the mean phenotypic expression of the two parents. Is it clear? Is it clear, or do you want me to explain again? Have you not understood? Understood or not? Yen kavisidre stop ಮಾಡಲಾ? ಸ್ಟಾಪ್ ಮಾಡ್ಬೇಕು ಹೇಳಿ, ಸ್ಟಾಪ್ ಮಾಡ್ತೀನಿ. ನೀವು
ಇಲ್ಲ ಸರ್
ಇದೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ಬಿಟ್ಟು ಕ್ಲೋಸ್ ಮಾಡ್ತೀನಿ.
ಸರಿ.
Deviation in the mean phenotypic expression of the F1 heterozygote. From what? Where is it deviating? From where? From the average of the two homozygotes. 50 plus 80 is 130. 130 divided by 2 is 65. If the F1 heterozygote has a mean phenotypic value other than 65, if it has 65, then there is no dominance. If the mean plant height is deviating from 65, then it is dominance. Otherwise, it is no dominance. What? Banu, did you understand this?
Yes, sir.
Did you get it? You made a cross, you take the F1. The F1, if it produces a mean plant height equal to that of the average of the two parents, okay, P1 and P2, then there is no dominance. Deviation in that, deviation from 65. Here we say it is no dominance. Here it is dominance. Here it is partial dominance. Here it is complete dominance. Here it is partial dominance, complete dominance, over dominance. Partial dominance, complete dominance, over dominance. In every case, you are getting dominance, right? This is the only case where you have no dominance. So deviation in the mean phenotypic expression of the F1 heterozygote from the average of the two homozygotes is referred to as dominance. Did you get the meaning of it?
Yes, sir.
Yes.
Henceforth, sir, can you please repeat? Who is this Banu? Artha agilva?
Yes, sir. Yes, sir.
ಆಯ್ತಾ ಈಗ? ಇನ್ನು ಮುಂದೆ dominance ಅಂದ್ರೆ the form that is expressed in the F1 ಅಂತ ಬರೆದ್ರೆ definition ತಪ್ಪು. ಅದಾಯ್ತು, PUC level ಮುಗಿತು. Did you get it? Did you get it?
Yes.
So what is dominance? Dominance is nothing but the deviation in the mean phenotypic expression of the F1 heterozygote. From where? From the average of the Main phenotypic expressions of the two parental lines. Clear? Clear? Shall I stop? Gavi, attendance alappa?
ಸರಿ ಸರ್ ತಗೊಂತೀನಿ ಸರ್.
Okay. I'll stop here. You can stop me at any point of time. Gavi Siddesh. Gavi.
ಸರ್
ಗುರುವಾರ ಬೆಳಗ್ಗೆ
ಸರ್
ನಿಮ್ ಕ್ಲಾಸಸ್ ಎಷ್ಟು ಗಂಟೆಗೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ?
ಸರ್ 9:30 ಸ್ಟಾರ್ಟ್
ಆಗುತ್ತೆ. ಈ ಗುರುವಾರ ಮಾತ್ರ, ಈ ಒಂದು ಗುರುವಾರ ಮಾತ್ರ
ಹಾ ಸರ್
ನನಗೆ 8:30 ಕ್ಲಾಸ್ ಕೊಡಕ್ಕಾಗತ್ತಾ?
ಸರ್ ಕೇಳ್ಬಿಟ್ಟು ಹೇಳ್ತೀನಿ ಸರ್ ಎಲ್ಲ.
ಕೇಳಿ ನನಗೆ ಮೆಸೇಜ್ ಮಾಡಿ ಸಾಕು. ಯಾಕಂದ್ರೆ 2 ರಿಂದ 3 ಅಂತ ಇದೆ.
ಹಾ ಸರ್
ಸಾರಿ 12 to 1 ಅಂತ ಇದೆ. 12 to 1 I may not be able to engage a class on Thursday. This Thursday only.
ಸರಿ ಸರ್.
Okay. After 5 is okay for me, but ನಿಮ್ಗೆ ಓಕೆ ಆಗಲ್ಲ. ಅದಕ್ಕೆ ಬೆಳಗ್ಗೆ 8:30 ಬಂದ್ರೆ ಮುಕ್ಕಾಲ್ ಅವ್ರ ಕ್ಲಾಸ್ ತಗೊಂಡ್ ಬಿಡ್ತೀನಪ್ಪ.
ಸರಿ ಸರ್.
ಕೇಳಿ ನೋಡಿ.
ಓಕೆ ಸರ್.
ಬಾಯ್ ಬಾಯ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
Right.